system. With every section, when we look at the structure, there will be a lot of bolded words. The bolded words you can expect, and we do expect you to know. Unlikely we'll be like testing you in terms of asking you to write essays on the structure. It's very weird. Instead, when we look at structures, very often the skill to pick up is to be able to identify the parts. If I show you the male parts and the female parts, can you identify correctly? Okay? So that's the first skill to pick up. And so when you look at all of this over here, look at this table, do you need to know and memorize all these descriptions over here? No. Okay? Don't expect you to be able to describe the male and female reproductive system. Instead, I expect you to be able to know how to identify. And if you want to remember anything, it is this last column that's more important, the functions. Okay? Don't need to describe. It's very weird. What can you describe about testis? Oval? Okay, so nothing much to describe. But instead, know the function, because this is where sperms are produced. Okay? So our role today, we're going to do two things. Number one, we identify the parts. Number two, we know the functions. How will we assess you on the functions? Maybe an MCQ. You encountered MCQs before where we give you a table, and then after that we give you some options, right? Structure, function. Then maybe there's A, B, C, and D. And here is structure number one, this structure function number one. Then we ask you which option matches the function correctly to the structure. Okay? So for example, questions like that. We will not ask you to write an essay. It's a waste of your memory space. But why start off with knowing the functions of the various parts? Because then it helps us appreciate how they work together later on. So let's begin first with the structure of the male reproductive system. I hope it still works. Can you click on the Google Sites link, not the first link on top? There are slight variation with the link, but I hope mine still exists. If you click on the Google Slide one, yes, okay, it's still there on my website. Did you remove it yet? The company that supplies these digital models, I noticed that every time I get students to visit my website, then they will declassify it, they will remove it from my website. Because they have changed their terms and conditions. Last time I put on the website, they still allow. But then recently they want me to pay for all the clothes. But I already put on the website, what do you want me to do? Is it still there? Still there? Okay, good. They've removed the eyeball and the heart already. Okay, I like this model because if you were to use the iPad, I think you should be able to do the same thing. You can look at it from various perspectives. Yeah? Okay, your textbook only shows a dissected 2D view. However, this model is better because it allows you to look at it from all various perspectives, which I think is much more valuable for yourself. So if you want to do a revision and you cannot visualize where everything is, come to this website, orientate yourself. Okay, so that's step number one. Okay, let's start off with identifying. As we identify, we also label all the functions. So by the end of today, you create for yourself 2 screenshots to the best of your ability. Okay? Each screenshot, you label as many parts as possible because that is the skill to pick up, to be able to identify. Okay, we start with the male repro system. The first thing we'll do today, we're going to do a screenshot. We try to identify all the parts. After we identify all the parts, then we will do, the last thing we'll do is to trace the path through which sperm will take. This is important because why is it important? It's important because this is national education, reproduction, important, low birth rate. Yeah? But also for general knowledge, it'll be very weird if you don't know where everything comes up from. Okay, so from the males, we're going to start with that now. Let's start off first with the diagram over here. Okay, just want you to take note, this is a 2D image. This is a 2D side view. Okay, don't go away with the impression that this is what is all there is to it. Okay, for example, males have 2 testicles, not just 1. Yeah, so this is just a dissected view. If you look at it from the front view, this is just 1 part. Okay, so don't go away with the idea that the organ looks like that. And then you can see patterns. Okay, there's no pattern, this is on the inside. Okay, let's identify as many parts as possible. First and foremost, I would like to identify number 1. The testicle. Okay? Here, I think there are 2 ways to describe this. Number 1, testis. Number 2, testicle. For biology, we prefer if you use the word testis. Okay? But if you ask me why, actually there's not much reason why. I don't know why testis sounds a little bit more sophisticated as a biologist. Okay? Okay, so work with testis. That is singular. For plural, is testis. I think with an E. Testis. So you replace the I with an E. Okay, that represents plural. More than 1. The structure of the testicle, if one were to dissect it into half, you'll find it's very interesting. Because inside each testicle, you'll find lots of tubes. Here's 1 tube, almost like a kidney. Okay, you find lots and lots of tubes, and the tubes all branch towards the output point. Okay, lots of tubes. In your textbook, they would have described these tubes and called them seminiferous tubules. So we scroll slightly further down. Where did they go to test these? Okay, over here. Seminiferous tubules. In your textbook, you also would find, I think we provided an image. This is what it looks like. So testicle dissected into half, actually lots of tubules. Okay, then let's look at function. What are these tubules for? Actually, that's where the sperms are formed. The sperms form within these tubules. Once they form, they will then exit via a common tube. That common tube not yet common tube. All these tubes will branch into one large pouch-like structure. And this pouch-like structure is the which I cannot spell all the time, epididymis. Here is where all the sperms will end up in first. So all the sperms will collect within this pouch first. What is the function of the epididymis? This is where sperms mature. They form within these tubes, but after they form, they will all go into the epididymis where they mature fully. That means structurally speaking, if I were to remove someone's epididymis, the sperms will not fully mature. These are structures that you cannot see in the virtual model because they are rather microscopic in nature. Now after the sperms have matured, they should all exit via a much larger tube, and that is what we are more familiar with, which I think you learned before in JH2, the sperm duct. This is also called the vas deferens. And this is the path sperm will take out of the body. Actually, we can even start talking about disruptions now. You want this guy to be fertile, right? What should you do? Just sever this thing up. Okay, sever the sperm duct. Okay, but of course we don't just cut it out. You need to tie it and make sure it's sealed. Okay, so after you sever it, I think you all learned in JH2 before, right? How we can, not make a person infertile, that's not the right word. I think it's a contraceptive. Okay, so after you slice it, then after that you will sew it back. You will sew up the ends so that any sperm that's produced can mature all they want, but they'll never find a way out. And that is how you can make a person not be able to produce any fertile sperms out. Sometimes students will then ask, what happened to the sperm? Like they all, only like this part swell up, if like they all congregate there cannot escape, right? Okay, actually your immune system will get rid of it. Okay? If there are a lot of sperms congregating here, the immune system will come in and digest it. So essentially your body is your own sperm. Gets back all the nutrients, take back all the cell membrane, take back all the proteins, use it for other purposes. Wait, sorry, that biologically doesn't make sense. Sorry, I take it back. You should only be able to absorb nutrients and your villi in your stomach. You cannot absorb nutrients in other parts of the body. Okay, so what will most likely happen is the immune system breaks down the sperm, and what will happen is there will be its weights, they will have to be removed from the body via bloodstream. Okay, so that is a zoomed in version. Now if we go back to this image over here, there is epididymis. So over here, let's look up over here. Where will that go? It's connected to the vas deferens. So let's go up. The vas deferens. Then if you have your virtual image, you can rotate to see where it goes. So it goes up, goes over the pelvic bone, goes behind this big structure over here. Curious? What is this big structure over here? What is this big structure that my mouse is at? That the vas deferens has to kind of skirt around. So we look at it from the front view. Hazard to guess what this giant bag is. Sorry, prostate? Okay, no. But the prostate is somewhere in the region. Anything else? Bladder, yeah. So that is where the bladder is. The vas deferens will have to go up over the pelvic bone, skirt the side of the bladder. Then it goes below the bladder. So you see where it connects up. Whoa. It's upside down now. Okay. It goes beneath the bladder and connects at the bottom. Let me see if I can remove the bladder. Okay, I've hidden the bladder. Now you see the vas deferens. Vas deferens avoids the bladder, goes behind, and then it connects over here into this kind of strawberry shaped structure. This tube will then go in to this strawberry-like structure and go down this tube, and then it goes out the penis. Okay? So that's the path sperm will take to get out of the male system. Unfortunately, for many generations, we provided a textbook image that almost gives the impression that the sperm goes into the bladder. And then the human being pees out the sperm from the bladder. It doesn't work that way. But I can see why people will get a misconception. Now, it skirts around the bladder. So you look at the image here, I think perhaps even the image over here may give you the wrong impression. Okay, this one is better. Okay, look at this image here. The vas deferens go up, skirts behind. Okay, but some students think it skirts behind go where? Then go inside the bladder. Okay, but biologically it doesn't make any sense. If all the sperms get ejected into the bladder, the urine inside is acidic, the sperms autodiarrhea. This image is better. You see the vas deferens go up, goes behind, it skirts around the bladder, goes into this strawberry-like structure, connects into the tube, which you know of as the urethra, where urine comes out from. Yeah? So it connects over here, then it will come out via the urethra found within the penis itself. Okay? So, misconception number one. Students often think from diagrams that the vas deferens connects to the bladder. It does not make any biological sense. You are sending the sperm straight to their death after they are formed. But that being said, you then notice there's something very odd about males then. Because if sperms take this route, they go up the vas deferens into this particular channel over here, which is the urethra out the penis. Then you notice something very odd. Because if I put the bladder back in, how do I put the bladder back in? Okay. Bladder coming in. A. What the? This is where urine is stored, right? Urine also come out here, right? Yeah. Okay, so that is the truth. Males, the sperm and urine take the same route. It goes out via the urethra. Same route. Aren't you curious then therefore how it doesn't like eggs? You all must ask a question, right? I'll ask my own questions, then answer my own questions. Okay, so how does it not mix, right? Okay. At the base of the bladder, there is a sphincter. Okay, a muscular sphincter. So this muscular sphincter, when it comes to ejaculation, this sphincter will constrict so that pee doesn't come out while sperm is coming out. When sperm is coming, so when you squeeze this, urine don't come out when sperm is coming out. Okay, then if you want to pee, this sphincter should be open so that pee can come out. And by right, when pee is coming out, this individual shouldn't be needing the sperm to come out. Okay, so that's how it helps to, it's kind of like a valve, to prevent two things from coming out the same channel. Because if it does come out the same channel, actually the sperms will die from the acidic environment of the urine. Okay, so that is the truth. It is unusual, but that is the biology of males. So if you are asked, therefore, to trace the pathway that sperms will take, I've seen students trace the pathway go like that. From the testicles to the epididymis, up the vas deferens, into the bladder, then come out via the urethra. Okay? That is the most common mistake students make. But always remember, there is like suicide for the sperms. They need to skirt around, and then it comes out via another way. Once that is done, then we can start talking about other accessory glands that are attached along the way. You'll find in your textbook some of these glands introduced to you. For example, you scroll down, seminal vesicles, prostate gland, Cowper's gland. I do not need you to memorize each gland produce what. No value to memorize. Instead, can you summarize to know that when we look at accessory glands, the function of accessory glands are to produce the components that make up semen. For example, produces mucus, produces nutrients. It also produces alkaline fluids. So I do not need you to know specifically each gland produce what. Don't need. Just a general understanding will do. Last but not least, when you combine all of these fellas with sperm together, this is what we call semen. Okay, so semen doesn't just contain sperm, it contains a lot of nutritious stuff. Mucus as lubricant for the sperms, nutrients so that the sperms mitochondria function so that the tail of the sperm can do its job. Alkaline fluids, because actually in the female Repro system, it can be very acidic. So the alkaline fluids is to neutralize the acidity, so the sperms can die. Okay, so go and memorize all the which gland produce what. A general understanding will do. For yourself, instead, know where these glands are. In your digital model, can you find these glands? glands. Functionally speaking, it makes sense for these glands to be attached to the tube when the sperms will go through. Okay? So number one, you see this brain-like structure over here, a tiny little brain, or half a brain. This is the these are the seminal vesicles. You see this large structure below the bladder, that's the prostate gland. That's where males often get cancer, prostate cancer. Notice that the glands surround where the tube is, because you need to produce these fluids, these nutrients, directly into the tube when the sperm is traveling. The corpus gland is very tiny. That's the one that I have trouble finding. I need to cut away other parts of the body. I can find it. I need to remove this part. Okay. So if you go and hide some of the parts and zoom in, you see this tiny little thing over here, like a little pea. Yeah. Okay. This is the corpus gland. It's also attached very closely to the urethra, so that it can nourish the sperms as they're going out. So know where the location of these three glands are, but don't need to know exactly which gland produce what. General understanding will do. And I hope you make sense of these factors, mucus for what, nutrients for what, alkaline liquids for what. Okay? Yes? Yeah, thought for a real question. Yeah, good, brother. Yes? Okay, does the sperm pass through the seminal vesicles? So let's look at the seminal vesicles. If you look at the structure over here, notice that the vas deferens go here, then they go here, and then they attach here, right? So the seminal vesicles, the sperms don't go through. The seminal vesicles kind of like, you know, your pancreas connected to your small intestines, right? The pancreas produce the liquid direct into the small intestines. Kind of similar here. The seminal vesicles produce the fluids into the tube, then the sperm and the fluids meet halfway. Yeah. So that's how it functions. So I've heard that, for example, one of the tests done to determine whether a person has, what is one of the symptoms of someone with prostate cancer? This prostate enlarges to the point where, do you know what this is behind? This tube. It is a rectum. This is where shit comes out. Sorry. This is where feces comes out. Okay? Feces comes out through the rectum. So if the prostate enlarges and starts to push backwards, you know what happens? One of the symptoms is that you feel like there is something, one lump inside, and then as you poop, like there's an obstruction. So that is one of the symptoms of someone with prostate cancer, because the prostate is enlarged because of tumors inside. Okay, we're almost done with the reproductive structures of the male. Notice that males not very complex. And nothing much to talk about. Other fun facts. So you look at the bone, look at the pelvic bone. So actually the pelvic bone offers no protection to the bladder. The bladder is over here. What overlays it will be skin and some muscle, your ab muscles, but the pelvic bone is kind of below the bladder. So you give any guy a good punch in this region, right? You may accidentally force some urine out. Okay? Okay, next thing. Look at the interesting tissue structure within the male. Notice that it looks like there are many compartments. Yeah? That's because there are many compartments. These compartments are richly supplied by blood vessels. And if the time comes and blood goes into these various chambers, then the bio word is, then this penis will become erect. A misconception is to think that there's a bone in this. Okay, there isn't. So there's no cartilage, no bone. The normal state is kind of limp. If, trying to use all the biological terms, if copulation is taking place, then these chambers will be filled with blood, kind of like a balloon, those long balloons you fill up with air, then it will become erect. That's how it can become functional. Long time ago, I've told you a story before, your seniors 4 generations ago, I saw one boy, one girl arguing. I've told you a story before. Yeah, I told you before. I told you all in your J. I tell you a story. Last long time ago, 4 generations ago, I remember this. One boy, one girl behind. When I was teaching this, I decided to skip this part. Because I thought, right, like, everybody should know, right? So after that, I decided to skip it. Then as I started to continue teaching about finger part, then boy and girl behind arguing. Argue until the boy cannot take it. Then after that, he said, don't believe, go ask the teacher. Then after that, the girl raised her hand and he said, Mr. Tan, can I ask if there is any bone inside the structure? Then I said, no, there isn't. Then the boy said, see, I told you, why don't believe me? Then the girl asked, you still don't believe? Then she said, what about cartilage? Oh, there must be at least some cartilage, right? I said, don't have. Yeah. Then she said, then how is it possible for it to be hard enough, right? To be able to carry out its function? Then I say, yeah, then I had to go and explain all this. So I explained first this time. Yeah, but apparently she got the idea that there's a bone because of the layman term that someone would use to describe. Yeah, I will stop there. Okay, so that is the biology of it. This is the male. I'd also like to qualify that this is not all of the structure. You will not find in males the testicles just hanging loose like that. Meaning to say, it's not like you can just hold the vas deferens and snip it that easily. There's a pouch of skin called the scrotum to contain it. It's not no protection, bacteria want to go in also can attack the whole structure. Okay? So that's the male. Next, we look at the parts of the female reproductive system. Oh, actually, on the contrary, I think there are less parts to look at. Perhaps let's find common structures. Where is the bladder of the female? So you have MCQ question. Imagine they point to here, they point here, they point here, they point here. Which one is the bladder? Okay, so it's actually very important to know. Because if you mix up biologically, it means your biology becomes very important. Where is the bladder of females? The bladder is over here. You see? You compare it to where the bladder of males are and the length of the urethra. You notice that female, the urethra is very short. Almost just up the urethra, very little bit is the bladder already. Look at males, however. Look at males. The urethra is much longer before it hits the bladder. This is one of the reasons why females are more likely to get this particular illness called urinary tract infection. The urinary tract infection is an infection of the urethra, where the whole tract becomes inflamed, lots of bacteria growing along the way. If the infection is bad enough, it can travel up the urethra all the way and infect your entire bladder. Once the bladder is infected and not healed, the next channel you'll go up will be up what connects the urethra to the kidneys? Ureters. So if the urinary tract infection proceeds, goes up the ureter, it can infect your kidneys, and you can get kidney damage. So females are more likely to get urinary tract infection because this urethra is so much shorter, bacteria is can get in much more easily compared to males. But the way around getting UTI, urinary tract infection, is to drink more water. When you drink enough water, constantly you go to the toilet, you are flushing out urine, then you will flush out the bacteria that's stuck in the urethra region. Okay, so that is one way to prevent UTI. If I were to remove some of these structures over here, you can see that the bladder of the lady is also connected to. Let's remove this structure over here. Okay, you can see the yellow structure going up. That is the ureter. This ureter over here should connect to the kidneys above. You find the same thing in males too. Notice that the bladder of females resides a bit lower. Actually, the pelvic bone is in front of the bladder. Instead, the structure above is a structure that is free from obstruction. You see this pouch over here. That pouch is the uterus. The uterus, in layman's term, is the womb. And it makes sense for the womb to be unobstructed by the pelvic bone, because as baby enlarges and enlarges, this is the region where mummy's tummy will start to enlarge and become bigger. Okay, it avoids the pelvic bone. So this structure over here enlarge bigger and bigger as baby grows bigger. Okay, so that is where the uterus is. We kind of use the word uterus and womb quite interchangeably. So up to you which one to use. Just be careful. Uterus, there are many biological terms that start with U, like ureter, urethra. You just be careful you use the corrector. Okay? For example, baby cannot be developing in the ureter. Be very painful. Baby develop in the urethra also be very painful. Okay? And also I don't know how possibly it could happen. Yeah, so we have a few pouches. Bladder connect to urethra, uterus connected to. Then let's identify other parts of the female reproductive system. Here you see this large tube over here. This tube over here. Okay, let's reverse back. Don't talk about the tube first. Look at the base of the uterus or the womb. I'm going to go to the base. Can you see at the base over here? There is an opening. I zoom in a little bit more, and I change it this direction. Okay, look over here. Can you see at the base of the womb, there is an opening? This opening over here is what we call the cervix. The cervix is also a muscle ring that is not open. And it makes sense why the cervix needs to be closed most of the time, because the baby is developing in the uterus, right? The cervix opens when it's time for birth. Say again, the cervix opens only when it's time for birth, but by right, it should be closed so that if baby is going to fall inside, baby won't suddenly come out halfway. Because as the baby is developing, actually it's very small, right? You don't want it to slip out before its time. Okay, so cervix is closed until birth. Then this channel over here, that is quite ripped. It's very ripped because it's very muscular, much like your intestines can carry out peristalsis one. Okay, it's muscular. This ring over here, this tube leading up to the cervix, that is the vagina. So biologically speaking, this is where sperm needs to be deposited. And after it's been deposited, it actually has quite a long way to travel before it can even reach the egg. Okay, so sperm is deposited here. And then from there on, it will make its journey to find the egg. Let's look at other structures connected to the uterus. Look at the outside of the uterus. You can see that there's one long tube connective tissue coming out. This connective tissue connects to the ovary. So you can see this white structure here. This is the ovary. The ovary is held in place by this structure over here. Can you see that there's this ligament over here, this tube? It's not really a tube, it's more like a ligament. It holds the ovary in place. The ovary is not floating around. It's held in place at a particular location. I used to think it's floating around. Another misconception I had was, I actually thought that this fallopian tube, you all in JH2, I actually thought last time that the fallopian tube is connected to the ovary and it's holding the ovary in place, which is not, no. So the misconception here is this: if this is the uterus, actually you have one ligament that holds the ovary there.